In this short video, we'll use PICWave to simulate the response spectrum of a ring resonator. This model we see in front of us here is the symbolic representation of a ring resonator, where we have waveguides and coupling regions that build up this ring resonator structure. The way that PICWave will model the ring resonator is for each of these waveguide sections, we either define the cross-section, and PICWave will calculate the mode information, such as the effective index, group index, and the bending loss. Or manually, if we've calculated that elsewhere, we can simply input the coefficients in this panel here. So here we've defined only for TE, a group index, effective index or group index, and no bending loss. So with this information provided into PICWave, along with in the coupling regions, the TE and TM coupling coefficients, again calculated elsewhere in this case, we can do a very quick but accurate simulation of the ring resonator using PICWave's TD-TW time domain algorithm. So I open the TD-TW calculator, I click run, it does a time domain simulation for 10 nanoseconds with an impulse optical source coming in the bottom left, and then go click the inspect button to look at the spectral results. So we have power coming in the bottom left. So let's look at the power coming out the bottom right. And we'll plot it on a dB scale against wavelength. So that's the power as a function of wavelength coming out the bottom right. 0 in this case is what's called the central wavelength of the simulation, which is 1.55, and then we're offset in nanometers. So then how about top left, the straight through power? So I switch over to the monitor called top L, which is the name of this monitor, and I can plot this one as well, showing you immediately the frequency response of this ring resonator as designed.